Hi everyone, welcome to CloudSoft Solutions channel. This is Srikanth. Total I have 15 years of experience in IT and it's more into cloud and DevOps. And I have worked with the tools like Docker, Kubernetes, Jenkins, Terraform, Ansible, most of the CI/CD tools. And cloud-wise, I have worked with AWS and Azure. In this video, I would be covering essential DevOps interview questions and answers, and I would be sharing insights and tips how to crack your DevOps interview. Whenever you have starting your DevOps journey or you want to switch your career into other job, this video would be useful for you. So grab a notebook, hit the subscribe button, and let's dive into the world of DevOps. So first, in the DevOps interview, mostly we would be getting questions. What is DevOps? Like for that, we need to answer. Like DevOps is some set of practices that combines software development and IT. Like it's a dev and operations have been integrated. What is the main purpose of the DevOps cycle is we need to deliver high quality software in a short span of time, and we should have good collaboration between development and operation teams. The rapid IT service delivery we required, and DevOps is some set of tools, practices, some process, and its philosophy in the IT. And coming to the principles of the DevOps. So next maybe the question would be, what are the key principles of the DevOps? So in this we have continuous integration, continuous delivery, continuous deployment. In that itself we are going to have IAC, infrastructure as a code, automation. Like if we shouldn't do the things manually, most of the things we need to automate using the DevOps practices. Then we should have good observability kind of things, monitoring and logging, and between the teams also, like dev teams, QA teams, operation teams, we should have very good collaboration and communication. So these are all the key principles of DevOps. So in that we have continuous integration, continuous delivery or continuous deployment, then IAC, infrastructure as code, automation, monitoring, and logging in the observability. Then we should have a good collaboration and communication between the teams. Then if any organization uses DevOps, so what are the benefits that DevOps, or what are the organization is going to get? So now here, what is the main advantage is faster delivery of the features. So now most of the companies today they're using agile or scrum kind of methodology. Like what is the advantage of using the DevOps is rapid IT service delivery. So we can deliver applications at the rapid phase, and between the dev and QA teams, operation teams, we are going to get good communication and collaboration also. And like in the project deliverables, we have reducing the risk and increasing the reliability also. And we are mostly automating most of the infrastructure provisioning or CI/CD kind of steps with the pipelines, and it's going to give like efficiency also, and it's going to be scalable. And security wise also we are going to have a lot of best practices in the DevOps. If any organization or project uses the DevOps kind of process, these are the advantages we are going to get. Then here we have CI and CD. So in the CI, that's called as continuous integration, and CD we have continuous delivery or continuous deployment. Okay, so what are the CI and CD? Maybe the questions we may get in the interview. So what is the continuous integration is? Continuous integration is one of the software development or software DevOps best practice, where developers are frequently integrate their code into the code changes into the shared repository. After that, we are going to build the code, unit testing, integration testing, static code analysis, and finally we are going to use vulnerability scanning. All these also we are doing, and finally we'll store that in the artifactories. So these all the steps we are going to perform in the continuous integration. So continuous integration is one of the DevOps or development best practice. What is the main advantage is the developers are keep on integrating their code into source code management. That's maybe a shared repository we are going to keep like GitHub or GitLab or Bitbucket. then automatically the pipeline is going to trigger, and with this we need to verify, we need to whether the build is working fine, dependencies are working fine or not, unit testing, integration testing, static code analysis, and quality gates, and even we need to identify the errors at the very early stage of the development itself. Okay, so that is the purpose we are going to use continuous integration. Then continuous delivery or continuous deployment we have in the CD. So we'll discuss more on the continuous delivery and continuous deployment. So now here in the continuous delivery, the software is always ready to be deployed into production, but the actual deployment required a manual approval or we have a intervention in order to deploy to production. That means we are keeping everything ready. So that means all the CI stages and dev, QA, staging, everything is done. But when we are going to deploy into the production, we are waiting for an approval. With an approval itself, that's maybe from the product owner or from the client, we are going to get an approval. After that we are going to perform. But if we go for the continuous deployment, whatever the changes we have performed, automatically we are deploying into production, and we don't have any manual approvals in the continuous deployment. Okay, so that means a manual intervention or approval is required for continuous delivery. Whereas for continuous deployment, seamlessly we are deploying even into the production also. So for the continuous deployment, we require a lot of maturity levels. Whereas continuous delivery, like we have an approval, and on that approval after scheduling, we are going to perform continuous delivery. Okay, so whereas which required manual intervention is continuous delivery required a manual approval or intervention, but whereas continuous deployment not required any manual intervention. And deployment frequency also, like continuous delivery maybe happens at end of the sprint, sometimes we may do at a daily also, but mostly at end of the sprint we are going to perform continuous delivery. Whereas continuous deployment, maybe multiple deployments also, each and every feature also, we have confidence on our CI CD process, then automatically we are moving our rollout into production also. Then risk wise, like here continuous delivery is a little safe. Okay, because we have opportunity to review and manually assess the risk before the deployment. But whereas continuous deployment, we require a lot of confidence on your CI/CD pipelines, infrastructure, your deployment process, in your regression testing also. Okay, so because a small risk is there, but we should have the confidence on our pipelines, then we can move to continuous deployment also. The complexity, continuous delivery is simple, but continuous deployment is more complex, and we required a lot of comprehensive testing and automated rollbacks, monitoring, because even if any unhandled situations happens or if any production deployment fail also, we should handle that failures in a better way, and without any human intervention, we should able to roll back the complete environment also. And testing also plays vital role in both, but continuous deployment even we require a lot of regression testing, unit integration, functional, all that performance also we need to do. Okay, then continuous delivery is suitable where like we want to release maybe on the weekly basis or maybe for 2 weeks, such kind of things, and we required complex kind of security compliances wise, we need to have a lot of regression testing. In that, better to go for continuous delivery. Whereas complete continuous deployment may be web-based applications, SaaS, and we are getting a lot of small changes fastly we want to deploy. In that environment, better to go for continuous deployment. Seamlessly, we are moving into those. And rollback also is planned and executed manually. Whereas if any fails happens, but continuous deployment, automatically we should have the rollback mechanism also. If any failures happens, it automatically it need to be reverted back to previous stable state. Okay, so then compliances wise also, Like continuous delivery is a better strict compliances we have and approvals we required. Whereas continuous deployment may be not ideal for that. Okay. And users also will have a before itself they may get a notification that also users may communicate also before itself. Whereas continuous deployment, it's automatically it's may be happening. Okay. So these all the differences between the continuous deployment and the continuous delivery. In your application, you can tell you have a continuous delivery. Okay, so then what is IAC? IAC also plays very vital role. All these days in the physical servers or virtual servers, mostly we have provisioned the infrastructure manually, but using the IAC, like what is the main advantages? We are provisioning the infrastructure using like configuration files. It's maybe YAML, JSON, or HCL kind of scripts instead of using the physical configurations. Okay, so the main advantage is it's programmatically we are controlling the resources and we are getting lot of reusability by using the IAC. IAC stands for infrastructure as a code, and we have the tools like Terraform, or we have AWS CloudFormation, Azure ARM templates, or we have Ansible. So these are all the tools we have in the IAC. Ansible is the leader in configuration management, but it can do IAC also. Then one more type of DevOps tool is we have the source code management tool or version control tool in the multi-developer environment. So we need to have like a practice that need to track and managing the changes. Every developer, what are the changes have been performed, we need to track them. That's also one of the essential DevOps tool, because we required good collaboration and the changes need to be handled in a better way. And if you don't like the new code, we should roll back to the previous versions. And we need to maintain the complete history logging, what are the changes we have performed. The tracking also is very, very important. For that, we have Git, or locally we have the Git, or in the cloud base we have GitHub or AWS Code Commit, GitLab, Bitbucket, and Azure Repos. So these are the different type of version control tools we have in the market. Then if any of the developer has been committed the code, we need to perform continuous integration and continuous deployment. Instead of doing all those stages manually, we have CI/CD tool. So what is the CI/CD tool will perform is like it's going to have the pipelines. That pipeline will have a series of automated steps or tasks. What it will do is it will perform the end-to-end CI/CD kind of operations it's going to perform. That means if any of the new code committed automatically into the source code, even we can trigger the pipeline. So we have the CI/CD pipeline tools like Jenkins, or we have GitHub also. Now we are using GitHub Actions, or GitLab also we can use, or Azure Repos. Sorry, in the Azure we have Azure pipelines. AWS having AWS Code Pipeline. So these are all the different type of pipeline tools we have. What is the main advantage is like if any of the code committed or say at the scheduled time or manually also we can trigger the pipeline. The pipeline having series of automated steps on behalf of us, like those stages are going to perform the CI and CD. Okay, so we have Jenkins, GitLab CI, GitHub Actions, or like we have TeamCity or Circle CI, Travis, Azure Pipelines, AWS Code Pipeline. So these are the tools we have in the CI/CD pipelines. Coming to the popular DevOps tools, in the version control we have Git, Bitbucket, and GitLab. Then CI/CD Jenkins, Azure Pipelines, AWS Code Pipeline. Then GitLab CI, GitHub Actions. Then like we have configuration management. So configuration management, once we provision the infrastructure, we want to install some software, some patches, some user management, services. See, these are all the automation, files management, folder management, All these we can perform using the configuration management tools. It's some sort of IT automation, and we have the tools like Ansible, Puppet, Chef. These all the configuration management tools we have. After this, we can use the containerization. For the containerization, we have the tools like Docker, Runc, Podman. So we have the different, say in order to deploy the microservices, we are using containers and container orchestration. In the container orchestration, we have Kubernetes or Docker Swarm, or we have OpenShift, we have, or Pivotal, Cloud Foundry, PCF. These are all the different container orchestration kind of tools we have, and Kubernetes is one of the leader in this. Then in the DevOps, even we required a lot of monitoring also. For the monitoring, we have Prometheus, Grafana, and previously we have Nagios, Zabbix, and for logging we have ELK stack, and even we are getting a lot of APM tools also. We required some sort of APM tools also. We required good knowledge. And coming to the cloud providers, so we have AWS, Azure, GCP, Google Cloud Platform. Then we have even Oracle Cloud Infrastructure and Ali Cloud, IBM Cloud. So we have the different cloud providers we have. Okay, so coming to Docker and Kubernetes is nothing but Docker is one of the containerization tool. On top of that, for the orchestration, we have the Kubernetes. Say Docker is a platform to develop, ship, running applications using the isolated containers as the tiny containers we are going to run. And Kubernetes is an orchestration. Automatically we can create the containers, we can scale up the containers, and we can perform auto scaling, deployments, updates, rollbacks. All these we can do. Very large scale microservices deployment also can be simplified by using the Kubernetes kind of tools. Okay, so it's an orchestration kind of tool to deploy the microservices. And what are the microservices is? Previously, we have the monolithic application. The complete application has been bundled into one entity, and we are going to deploy those on the physical servers or virtual machines. But now we have the microservices where we have re-engineered our application architecture, like where applications have been built as collection of loosely coupled microservices, and the complete application code has been divided into multiple like microservices, and those microservices we are deploying into either containers or container orchestration kind of tools. So for that we have Docker, Kubernetes, or in AWS we have ECS or EKS, or in Azure we can use container instances or AKS clusters in order to deploy these microservices. Then what is the role of automation? Automation scripting also plays very vital role in the automation. Like we are using lot of tools, but there would be some kind of a patch kind of activities or some gaps we need to fill by writing the automation scripts. And in order to deploy the applications or in order to speed up the process also, we are using the end-to-end complete automation we are going to perform. Okay, and sec by using the microservices, we are using the containers to deploy, whereas the virtual machines normally we use physical servers or virtual servers or cloud-based EC2 instances, Azure VMs. Those are like consume lot of resources, and in order to scale up also it will take lot of time. But if you use the containers, what is the main advantage is we are getting lightweight, portable, and isolated kind of containers we are running on top of Linux, Windows, or Mac. We can scale up the applications very fastly, and even it's a stackable group of multiple microservices also we can deploy as a single stack. That is the main advantage. And in the newer DevOps kind of deployments, Docker and Kubernetes are playing the vital role. Okay, and easy to deploy across the multiple environments also by using the containers. And when we go to the deployment model in the DevOps, so we have mainly two things. One is canary kind of deployment, and the second one is blue-green kind of deployment. In the blue-green kind of deployment strategy, we are going to maintain the two versions of the environments. We have the blue version. The current users are connected to the blue version, and we are going to upgrade a newer version also, the green environment. And once we deploy directly, we don't redirect the traffic. We are going to perform the complete regression testing, performance testing, all those we are doing. And once we validate and once we got the approval, we are going to switch from blue to green, maybe using the load balancers, or in Kubernetes we have the ingress. So with those tools, we are switching the traffic between the blue to green, and like we, we are ensuring to the customers, like with the zero downtime, we can move your applications from one version to another version. And even if you want to roll out also, it's easy to revert back also. So that is the main advantage of using blue green deployments. So that is the main advantage. Okay, so already we discussed continuous integration and the continuous delivery. And whereas in the canary deployment, say we have the canary deployment like gradually based on the percentage, maybe 5%, 10%, we are going to roll out to the newer environment. Say, but in the blue green deployment, at any point of time, the users are connected to either blue version or green version. But in the canary deployment, at the same point of time, some of the users may be connected to older version, some of them may be connecting to the newer version also. But completely we are not upgrading. First, we are going to a subset of some percent of users we are upgrading, then we are testing, later we'll move the entire user base we are going to upgrade. Okay, so then we have in the DevOps anti patterns, what we shouldn't have in the DevOps is manual testing or manual deployments are not required. Definitely we need to use the tools like CI/CD tools, IAC kind of tools, then containerization, configuration management, and complete regression testing we need to do through the automation. Like this we need to maintain, and we should have very good communication also between the teams, and we shouldn't delay the deployments also. And some of the companies are treating development is separate team or operation is separate team, but we shouldn't maintain like that. Better to keep cross platform kind of resources in the team also. Then over complicated CI/CD pipelines also is not a best practice. Better to keep simple multi-branch kind of pipelines, better to keep. Then what are the monitoring and logging is going to be performed in the DevOps is, like monitoring is going to track what are the system performance, or we have Kubernetes container level, ECS, EKS level, and we need to verify network level also, disk operations, all these we need to track it. And in order to provide the help or the support wise to prevent the major challenges, monitoring also plays the vital role. And even we need to give the logging also. What is the main advantage of the logging is, we need to record each and every logs, and we need to store them in the ELK kind of stacks. So for the logging, previously we have log4j, but now most of the people are using ELK. ELK is a stack of Elasticsearch, Logstash, and Kibana. So using these kind of tools, we need to logging. And even in the monitoring also, now we have Neuralink, Datadog, Dynatrace, Splunk. So these kind of tools also, Prometheus, Grafana, these kind of tools also is getting more popular day by day. And in the DevOps, even security also plays very vital role. And definitely we need to incorporate security kind of practices also in each and every phase of the SDLC, and even in the DevOps life cycle also. So even in everywhere we need to provide security scanning, and we need to have the compliances. Then we need to stop if a pipeline, if the quality has been not met at the container level, Kubernetes level, cloud level, and even on the EBS, like a database level. We need to encrypt even every level. We need to implement the security best practices we need to follow. And while passing your sensitive details also, like secrets or credentials, or we may have API keys, key pairs, we should have very good best practices we need to follow. And regularly we need to assess the vulnerabilities. Up to date patching also is very important in our Citrix environments, or in the DevOps wise, in the cloud environment. These all very important. And coming to what are the tools we have from the AWS wise, AWS having vast set of services related to infrastructure, PaaS, SaaS, then AI, ML, but even they have good number of DevOps tools also. That in the AWS DevOps services, you have code pipeline. Like just like in the CI/CD, we are going to have the Jenkins pipeline. Here we have the AWS code pipeline, which will automate the release process. And in the AWS we can use CI/CD instead of using Jenkins GitHub Actions. We can use code pipeline service. Then if you go for the code build, like in order to build your packages to deployment, we can use. Otherwise, we have code deploy. So we can deploy your applications after build using the pipeline. We can deploy to EC2 instances, or we can deploy Beanstalk, Lambda, ECS. Set to these environments we can deploy. And even it supports blue green or production rolling updates also we can do. And even rollback also can be managed. And some environments it supports on premises also we can deploy. Then code commit is nothing but it's a version control kind of tool. Normally we have GitHub Actions, Azure having repo, but in AWS we can use AWS code commit we can use. Then coming to CloudFormation, in the IAC, like Terraform is one of the leader, but from AWS wise, even we can use AWS inbuilt solution for the IAC is CloudFormation. Using the CloudFormation, we are creating group of resources using the stack, and on the multiple accounts, multiple regions, we can provision the resources using stack sets. And Beanstalk is one of the platform as a service which provides pre-configured environments, like for deploying a Python base or Java, .NET or Node.js kind of PHP based applications by using the Beanstalk. Beanstalk uses in the backend CloudFormation for the automation, and automatically we can deploy our applications, and even we can roll back also if any failure happens. Okay, and easily we can integrate with the code pipeline, and we can deploy your applications into Beanstalk also. But one of the challenge with the Beanstalk is whatever the samples have been given by AWS, it works very well, but with our applications it's throwing some issues. That is the reason Beanstalk is not that much success. We are using Lambda for the serverless, or we are using ECS or EKS for the microservices, or we can use VMs or auto scaling groups also we are going to use. And even in the monitoring we discussed, right, in the DevOps, it plays very vital role. And we have in the CloudWatch is the monitoring solution from the AWS, and the ops work also, like is one of the configuration management service where using the Chef and Puppet we can automate the infrastructure, and we can use the patching, configurations, deployments, all these also we can use. And another AWS automation solution is System Manager, and we can automate our operational task, patching kind of activities, and we can do any of the scripts execution. All these we can do using System Manager. mostly for the patch management, for compliances on the AWS resources, inventory to collect AWS inventory. All these we can use. System manager we can use. And for the AWS, we have serverless kind of environment to deploy our applications without requiring a single server like EC2. We no need of databases. Using the serverless application deployment, the complete application can be deployed on the Lambda itself. So where it supports event-driven architecture, and even using the AWS DevOps solutions, we can integrate with deploying your event-driven functions or serverless applications, or even microservice based also, we can deploy into Lambda. Then auto scaling is infrastructure feature, and container level, like normally we have Docker, but AWS managed container solution is ECS, and we have EKS is nothing but Kubernetes kind of service. So which is a managed Kubernetes service we are going to use. And we have CloudWatch for the monitoring, and even if you want more like debug distributed applications, in the microservice kind of applications or serverless also, we can use X-ray for the like debugging your distributed applications, and it provides deep insights into your application performance or application like bottlenecks, root causes we can identify from the metrics which we are getting from the X-ray. So we can use for Lambda or ECS, or for Beanstack we can integrate. Then in the Azure, we have Azure Artifactory. In the same way, AWS also has provided AWS Artifactories. We can use AWS security and compliances reports. All this we can get it from the Artifactories. Then for the security purpose in the SecOps, on the cloud level, we can use like Security Hub, which is a unified security kind of solution for the AWS environment. And whenever we have the sensitive data like uh, passwords or certificates, API keys, is recommended to use the secret manager, or in Azure we have Azure Vaults, and we are going to store the credentials securely, and from that we are going to pass those details into your pipeline. Those details we are going to pass it to the pipeline, and definitely we required good expertise how we are going to pass the sensitive details in the tools like Jenkins, Terraform, Kubernetes, even at the application level also. And from cloud wise, we require the tools like AWS Secret Manager, or we have HashiCorp Vault or Azure Vaults also. We require the knowledge. Then AWS guard duty, which will provides if any malicious activity have been or unauthorized access happened to the Kubernetes clusters or for AWS services, it is going to provide intelligent threat detection. Also is going to provide for even EKS clusters also. For the security purpose, it's recommended to use guard duty. It's going to detect those potential threats at the early stages itself. And if any suspicious activity found on the VPC level or on the EKS cluster level, it will report. Then CloudTrail is used for auditing purpose. What are the administrative events have been performed? We can track by using CloudTrail. Then even as the Lambda, we have step functions also. We can use that workflow kind of deployments we can use by using step functions. And we have long functions, long running process functions, because in the uh, in the Lambda only it takes 15 minutes to execution, but we can divide that into step functions. We can divide. And CodeStar is a complete DevOps kind of solution, like very easy to deploy and applications. It's a unified kind of solution from AWS. Okay, so in the same way AWS we have, in Azure also we have the Azure DevOps kind of services. In Azure DevOps also we are going to maintain different tools like where Microsoft providing you simplified and very good DevOps kind of solutions have been integrated by using Azure DevOps organizations or Azure DevOps tools, and we can perform CI/CD, and we have a collaborative development is going to provide. Say in the Azure DevOps we have Azure repos, just like GitHub we have. In the AWS we can have code commit, but in Azure we are going to maintain like Azure repos. Even we can use Git or TFS also we can use. Then Azure pipelines, just like Jenkins we have our GitLab CI, or in AWS we have AWS code commit. So now here we are going to use Azure pipelines. Say in the Azure DevOps we are going to done all the all the pipelines. Using the Azure pipelines we have classic one, like through GUI we can configure, just like in Jenkins we have freestyle, or we can use the YAML kind of code also. So mostly we are going to use YAML kind of code in order to deploy our applications into Azure resources. And it supports like agents also. That agents may be Microsoft managed agents we can configure, or self-hosted agents also we can set up. And in that also different operating systems like Windows, Mac, Linux, all these also we can deploy. And we can deploy to on-premises also, we can deploy using the pipeline, or in Azure. Some use cases it may supports other cloud service providers also we can use. And even in the repos also, we don't need to use only Azure repos. It can integrate with the GitHub, GitLab, and even Kubernetes. All these also we can use. And Jenkins uses the Groovy kind of scripting, and in that we have two types of scripting, like declarative and scripted. In the next videos we'll discuss on the Jenkins also, but here Azure repos will use YAML based kind of definitions. And we have Azure board. So mostly we are going to use Agile, like a Scrum, Kanban kind of methodologies we are going to use. And for that, instead of using Jira, those kind of project management tools, like Azure itself is providing in the DevOps, Azure boards. And it supports Kanban boards or Scrum boards. What are the backlogs we have? Say in order to manage the Scrum or Kanban kind of Agile frameworks, we can use Azure boards. And even we can use Azure test plans also, where we can do the automated regression testing tools also we can integrate with our pipeline. And what are the package management tools and all these dependencies, just like we have AWS artifactories, here we can use Azure artifactories also we can use. Okay, and even Azure repos we can integrate with the GitHub repo also. Either Azure repos we can use, or GitHub also we can use. And we can do the testing, all these also we can like a dev test environments also we can provision using Azure dev test labs. And in AWS we have CloudWatch for the monitoring. In the Azure we have Azure Monitor in order to monitor those. And for the security, like we can do the security assessment. And even our pipelines wise also, like any threat detection, security alerts, all these also we can monitor from the Azure Security Center. And we can use container instances, AKS clusters, app services, or we can deploy the applications into VM scale sets, or serverless. We have Azure functions. So for these services, from the Azure DevOps, we are creating a service connection, and we are deploying into these services. And what is the main advantage of Azure DevOps over the traditional tools is, in the traditional DevOps, we need to integrate all those tools that's require a lot of maturity. But with Azure DevOps, it's very simple. And we have all the tools have been integrated. And whatever the tools not available, even very easily we can get it from the marketplace also. And a very high scalable kind of thing, even a small scale company can use, or very large scale applications also can use. And it supports cross platform. It's not only for Microsoft kind of deployments, even Java based, Node.js, Python, like most of the like a cross platform kind of tools are supported in the Azure DevOps. And we have very good stable pipeline solution is there. Even integrate even with the GitHub Actions also we can integrate. And on premises we can do, or multi-cloud also we can deploy, and very easily we can integrate with Azure boards, repos, then Azure tests also with the QA teams also very easily we can integrate. And vast set of marketplace tools also is available with Azure DevOps. Okay, so we can perform CI, CD, IAC, all these also monitoring, feedback, testing, all this continuous monitoring, reporting, continuous testing, all these also we can perform by using these tools. Then coming to the advanced interview questions, people are going to ask. So now the new method or modern approach is GitOps actions or GitOps is that like where we are going to perform CA kind of tools. We no need to use a third party tools like Jenkins or TeamCity. We are going to use like Git itself as our GitHub itself as a single source of truth, and all that we are managing from the Git itself or GitHub itself. All the infrastructure provisioning or deployments, all these also from the Git itself we are going to manage. So we have a lot of advantages. It will enhance our DevOps process, and it's going to be automate the infrastructure provisioning, and even updates rollbacks also is very easy. And additional to this is going to provide the version control even not only for the code, even for the infrastructures, for updates, releases also it's going to provide. And in our DevOps process, definitely every DevOps engineer need to know how we are going to pass our sensitive details. Say in this, we need to store that secret somewhere, like that's maybe HashiCorp Vault or AWS Secret Manager or Azure Vaults we need to use, or we have a leader in that HashiCorp also we have the vault, and the client also in the production deployments is going to use HashiCorp Vault or AWS Secret Manager or Azure Vault, and how to manage that with your pipeline or with your IAC, with your containers, orchestration kind of tools, and even at the database level also how we are going to manage. We require very good expertise, how we are going to handle the sensitive details or secrets in the DevOps we require to know. Then coming to like um, nowadays, lot of companies are using like multi-cloud kind of environment. Some of the infrastructure they have in AWS, some of the infrastructure in Azure. We should have that monitoring experience, provisioning experience using Terraform, and managing, controlling all this troubleshooting. All these skills also we required to manage the multi-cloud kind of environments also. And blue green and canary deployments. Say in the blue green deployment, we are going to maintain the two versions of the environments we are going to maintain. One is the blue version, and the second one is the green version. And we can switch between like a blue to green. At any point of time, we are going to maintain the either blue or green we are going to maintain. But if we go for the canary deployment, we'll have the only one environment, and gradually we are uh, uh, some percentage of the users we are upgrading to the higher versions. Our users or servers we are increasing the percentage, maybe 5%, 10% like that. Gradually we are promoting to the newer version. Okay, so but small risk is there. But in the blue green, we require a lot of infrastructure or double the infrastructure is required. Whereas canary is little we no need of that much infrastructure. Okay, then even in the DevSecops, so definitely we need to integrate like sensitive details and all the security testing, then vulnerability scanning and unit testing, integration testing, and even in the GitHub also we can integrate a lot of security practices at the container level also, Kubernetes level also. We require lot of testing is required, and even sashed dashed also we need to use using the sonar cube, or even we have dynamic application security testing, and container level also we need to use like uh, Anchor or uh, Trivi kind of tools also we need to use. So in the microservices, we'll discuss about the service mesh, and uh, we can scale up the infrastructures. All these also we are going to get more questions. And Kubernetes wise, we'll discuss the Helm charts, all these. Okay, so then some of the people are asking what is the difference between Terraform versus CloudFormation, or Terraform versus ARM templates. Whereas CloudFormation or ARM templates are specific to one particular resource, but Terraform is the leader. So compared to CloudFormation or ARM templates, Terraform is the solution we can use, and we have rich set of modules are available, and we can manage the state file locking. So these are the features we have with the Terraform. And how do we ensure the monitoring, observability, logging? We are going to use Prometheus, New Relic, Datadog, Splunk, then ELK kind of stacks also we are going to use. And even we can use open telemetry also for the distributed tracing. We can use open telemetry, and even we can collect the metrics, and we can use Prometheus and Grafana, and we can visualize monitoring using the Grafana, and we can use the Kibana for the application logging. So for that purpose, we are going to use these all the monitoring tools. And what is the difference between Docker Compose and the Kubernetes is, normally Docker Compose is not the competitor for Kubernetes. Docker Swarm is one of the competitor for the Kubernetes. For the small scale applications, we can use Docker Swarm, but for the production workloads, high scalable, highly proven solution is Kubernetes. So it's a full-fledged container kind of orchestration where we can deploy, scale, and manage production workloads on the Kubernetes clusters. Whereas for the small and medium kind of enterprises, we can use Docker Swarm or ECS kind of solutions. But for the production workloads, better to go for the Kubernetes. And here we would be some questions like how you are going to optimize. Say we have optimize your CI/CD pipeline. Like always, we need to review our CI/CD pipelines, and better to use the pull request kind of mechanisms even in the GitHub. Even for these pipeline changes also, better to have one review kind of mechanism. And we need to say, suppose if we have more agents, then we can scale up that application deployment fastly. And even in your pipeline also, instead of all the sequential steps, instead of using, better to go for the parallel kind of parallelization we can implement. And dependencies will take a lot of time to install, either if you have Maven or container level, better to use the caching also, or the Docker layers or npm packages in Maven dependencies. That will reduce the time, and even the size also can be reduced. And incremental builds also, only build and test the components if any changes have been performed. And we need to optimize like unit test cases, integration test cases at the early stage. Even we can identify the issues at the very early stage itself. And even for the build also, we are performing at the very early stages. With that build related issues also we can identify. And always is one of the best practice we have learned is we need to store the artifactories using JFrog. Nexus is one of the best practice, and even static analysis and vulnerability scanning also we need to perform. And our company, maybe what are the challenges we have, like in order to migrate to the DevOps culture wise also, like maybe definitely the traditional kind of teams will give a lot of resistance because they don't have the skills, or they don't have the automation capabilities to perform. Okay. And maybe like one of the challenge otherwise is not identify the right set of tools also. And that is also one of the challenge we'll face. And cultural wise also, We have the separate teams and a lot of egos between the teams, no communication, collaboration. So that's also maybe takes some time, and we require a lot of maturity with the engineers also. Very closely, they need to work with the dev and operation teams. And security constraints also, we need to have a lot of security and the policies we need to enforce, compliances we need to enforce. Even we're adding more automation, and we need to have good monitoring and observability. Logging also plays the vital role in this. And mostly what the main advantage we are using is blue green deployment. With that, we are going to get zero downtime. And monitoring wise also, a lot of APM tools and lot of observability tools are coming. We require good knowledge on the vast set of tools now. Like a lot of people are asking, monitoring, logging, uh, distributed tracing also. A lot of tools also came like Datadog, Splunk, or we have Prometheus, Grafana. Even from the traditional AWS, Azure monitoring solutions, logging solutions, we required good knowledge. And even like SRE kind of wise also, we required what are the SLA, SLO, then error like budget. So these kind of terminology also we required good knowledge. And on the Docker level, Kubernetes level also, definitely we need to use image scanning kind of tools like Trivi, Anchor, or Aqua Security, Claire. So using these, we need to scan our images. And even in the ECR, ACR level also is one of the best practice. We need to enable advanced security scanning. And on the Kubernetes level, definitely we need to have RBAC or IAM level policies we need to enforce. And we need to spot security policies, network policies we need to apply on the application level to isolate the pods. Then mandatory, we need to use the secret kind of management also we need to use for the sensitive details. So these are the security practices we need to identify. And mostly like we will be getting the questions, one or more microservices having some IO related constraints or CPU memory. We need to check that monitoring information, and we need to use the monitoring tools like Prometheus, Grafana, or we need to have the application insights. From this, we need to identify the root cause. Then we need to scale up the microservice also. If we have more consumption of that, more users are connecting, better to scale up either vertically or horizontally. We need to scale up, and we need to cascading failures. If any of the failure happens, we need to use the probes also, and we need to prevent cascading of the failures more also. We need to identify at early stage, and we need to isolate the failures also. And we can configure the rate limit kind of settings on the APIs level or microservices to restrict the load also on the microservices. And definitely we need to use auto scaling, HPA, VPA also we need to configure. Okay. Then, like here, we need to have how we are going to set up high scalable and high resilient CI/CD pipelines, the multi-region or multiple say infrastructure. Maybe like I have two regions or three regions I have, and I want to deploy updates, all those in my multiple branches, multiple deployments we need to use, and with the zero downtime, all these like production deployments, monitoring, observability, rollbacks, all these also we need to set up, and what are your approaches in your company also we need to make sure. And how you are going to secure with the like a CI/CD pipeline wise scanning tools, and even code level scanning, securities for the like a Docker level, image level, and compliance level, vulnerability scanning, image signing, compliance adding, then whitelisting the code, policy enforcement also. Now even open policy agent, OPA kind of tools also is getting more popular. We require the knowledge in all these kind of tools also. Then, like deployments already we discussed, blue green. These also we need canary, then A/B testing, automated rollbacks. We required good knowledge. and this one we'll discuss on the Kubernetes. We'll discuss how we are going to use the high applications on using EKS or AKS, and IAC also. Like, what is the main advantage of Terraform is it supports multi-cloud kind of environments, and even it supports a hybrid clouds also is going to support. So these kind of tools we need to use to provision the infrastructures, even we have multi-cloud or hybrid client kind of environments. Okay, so then, like, we need to discuss the migration strategies, and even we have the cross team kind of collaboration, and we have the different type of teams, silos teams we have, but we need to merge them into the single team. Okay, so all that we need to perform, and we need to have the good retrospective meeting or postmortem kind of meetings also, and we need to communication between the teams, all these we need to perform. The cultural level changes also we need to implement, even not only the automation, not only the tools integration, even this also plays very vital role. Okay, and for the high availability of the application, and the right sizing of the images, or right sizing of the VMs, right sizing of the Kubernetes cluster, application resources also like pods, all these also very important. And we need to identify these all the things also. We need to identify, and we need to use the monitoring, and budget wise we need to use AWS Cost Explorer or Azure Cost Management, and we have trusted advisor. With this we can provide right sizing and cost optimizations we can provide. And even in the SRE we need to have the disaster recovery strategies at the DNS level, and multi region deployments, replications, then cross region replications, sometimes AWS to Azure, Azure to AWS kind of communications, and disaster kind of setups we need to keep. And even like periodically we need to perform disaster recovery drills, and we need to make sure we are able to restore even if any disaster happens. And we should have good knowledge on the metrics like RTO and RPO also. We required good knowledge. Okay, so then mostly we would be working with the uh, finance kind of applications, or pharma, or maybe some of them are region wise like Europe wise, UK wise. So there we have the regulation authorities like we need to, if it is payment kind of systems, we need to use PCI, and even in the Europe we have GDPR or HIPAA. Those kind of regulatory compliances also, if you are working with the financial kind of or medical kind of things also, we need to provide. And even we need to use the policy as a code also. In the Terraform level we have Terra Grunt or OPI. So these kind of tools also we require good expertise as part of our like compliance level. We need to have these kind of tools also. And some ITL level also, like we need to have like if any production issue or any environment related issue comes, we should able to answer how you are going to assess that, how you are going to identify that, and how you are going to provide the solution, how you are going to fix it, or we are going to provide the workarounds. All these also we need to have the good ITIL, like in the incident management, problem management, change management. So these all that also, like terminology wise we required good environment, like a good knowledge we required. Okay, so then, like we need to use the what are the new tools and technologies also coming in the DevOps, like maybe how we are going to use new tools and technologies, and how we can use AI kind of tools also we need to have. And even one of the very important role we required is capacity planning, performance optimization for your pipelines at the infrastructure level, application level, database level. All these also we need to continuously need to assess, and need to provide the solutions also to the application level. And we are getting even some questions on AI ops or ML ops, or maybe like generative AI level also we are going to perform. those tools also we need to integrate. Okay. So these all, like, we need to have the questions. And coming to, like, now in the modern approach, we are integrated even the security also. Even if we don't use DevSecops also, mostly it's part of DevOps itself. But some companies specifically may use DevSecops. Even, like, we need to focus on security aspects also, and we need to integrate with security tools on each and every stage of our development life cycle. And definitely we need to have DevSecOps. Okay, and how we can bring that at the security at the like a pipeline level is, we need to use unit testing, integration. Then we need to use SAST, kind of static application security testing, then dynamic security testing, container level, Kubernetes level, how we are going to maintain the sensitive details. All these we need to use. And even like we required a lot of security for the microservices deployments on Docker and Kubernetes. And the compliance check also, we have Kubebench, or we have Anchor, Trivi for the image scanning. There are a lot of tools like Aqua Security, Twistlock, and even on the ECR, ACR level also. And we need to enforce the policies on the OPA level. And Kubernetes level also, we need to use RBAC or IAM level. Then we need to have pod security policies, network policies, and AWS, sorry, Kubernetes secrets we need to use. These all we need to make sure. And definitely the open standards also we need to take care, PCI or GDPR, HIPAA, and encryptions we need to enable, like KMS on EBS volumes, or S3 bucket level. And we need to use TLS SSL termination on the ingress, or application load balancer, or web servers level also, using the secret manager we need to generate the secrets also. We required certificates also, we require good knowledge, AWS certificate manager level also. And how we are going to pass the sensitive details, already we discussed. We may use HashiCorp or Vault or secret manager. And even periodically we are going to rotate also. That means whatever the credentials we have after 30 days, 60 days, we will be rotating those also. How we are going to handle this automatically also, we need to have the good knowledge. Okay, so then we need to integrate even in the infrastructure level, at the like Terraform level, TFSec, or compliances using TerraGrunt. So that's even CloudFormation Guard. So these also on the IAC level also, we need to enforce the compliances, policies, all those also we need to handle. And how to handle incident response in the ITL, we need to know, like maybe we are using Jira, ServiceNow, these kind of tools we require. And we need to assess the, prioritize, categorize the incidents, and we need to fix the solution. These all we require good knowledge. And for this we need to use the monitoring, like APM kind of tools also. We need to have good knowledge. Okay, so vulnerability wise also, we have a lot of dependency scanning, all these also we need to use. And in the AWS also, like in the cloud security wise, we need to give IAM roles or Azure AD. And we need to enforce the policies also. And always to the users, better to enable multi-factor authentications, and encryptions on the EBS level, S3 level, application level also. We need to enable database level also, we need to enforce the encryptions. Then, like, we need to use flow logs, VPC level, we need to enforce the NACL security groups, flow logs, we need to enable DDoS protection, firewall we can integrate on top of our VPCs. These also we need to have the network level also, securities we need to check. Then, like in AWS, we have Guard Duty, Azure Security Center, GCP Security Command Center. From this also, we need to have the intelligent threat protection. All these we need to provide. Okay, so then, like we need to integrate a lot of scanning kind of tools also, we need to specify. Okay, and up to date patching also we required, and any vulnerabilities also there, we need to assess those kind of vulnerabilities also. And for the patching purpose, on top of Linux we can use Ansible, Chef, or we can use AWS wise, AWS system manager also we can use for the patching. Okay, and at the API level also we have API gateway or Azure APIM. For that also we need to provide encryptions and authentications. All these also we need to provide for the APIs also. At the REST API level also we need to provide the encryptions and authentication, authorizations, rate limits. We can integrate even the cache, web application firewall kind of rules. All these also we need to add to your APIs also in the cloud environment, and even in the microservice kind of environment also. Okay, and definitely in the image level also, after you build through the Docker, it's mandatory before pushing to the registry. We need to use the scanning, and always use the official base images or minimal images like Alpine or official images are recommended to use, and don't give root access inside the container. Always we need to give the non-root access we need to use, and always use the signed container images which we can get it from the container registry. Okay, so that's these are the best practices we need to follow. These are the best practices we need to follow from the image level on the Docker. Okay, so then AWS level also we need to mention the IAM policies. Always we need to use the least privileges also to the users. Unnecessary permissions we should don't give, and role assumptions or assume kind of roles. These all we need to use, and better to enable the MFA also. And the Kubernetes level also we need to use pod security policies, network policies, RBAC, secrets, and continuous auditing, trialing, logging. These all policy enforcement we need to use. And for the CD also, like we need to use the Jenkins we need to use the project based matrix rules, or even in the like security level also checks we need to use, and the infrastructure level also we need to provide the sensitive details, vulnerability scanning. All these we need to provide in our pipelines also. Okay, so these are the most important like interview questions we would be getting in the next series of videos. We'll be discuss more on the Terraform wise, Docker, Kubernetes, Ansible. Those all we'll discuss. Then finally we'll come to SecOps related and SRE related also we'll discuss. So thanks for everyone, and will please subscribe to the channel for the next videos.